Hello guys, my name is Bino, and in this video we'll be going through question 1 from the April 6, 2021 Mathematics N6 question paper. And 1.1 we are given z is equals to a to the power 3x minus 2y. And question 1.1 we are required to determine the partial derivative of z with respect to x. So we have to determine the partial derivative with respect to x, so we'll treat that 2y as a constant because it doesn't have any x attached to it. So we know that when we have y is equals to e to the power x, when we differentiate y with respect to x, we have to lean the base, then e multiplied by e to the power x. So dy will be equals to dx. dy over dx will be equals to ln e is equals to 1. So this will be equals to e to the power x. But in this case, the base is not equals to e, so we have to lean the a and multiply it with a to the power 3x minus 2y. So according to the chain rule, we also have to differentiate the exponent. So the derivative of 3x is 3, and the derivative of negative 2y will be equals to 0, since we are treating this y as a constant. So this will be equals to 3 ln of a multiplied by a to the power 3x minus 2y. For question 1.1.2, we can write this as so now we'll be looking for the partial derivative of this whole thing with respect to y, and we just determined the partial derivative of z with respect to x as 3 ln a multiplied by a to the power 3x minus 2. So in the place of this partial derivative of z with respect to x, we substitute 3 ln a multiplied by a to the power 3x minus 2y. So now we have to differentiate this with respect to y, so we will treat this x as a constant. So the 3x, we will treat it as a constant. So this is a constant as well, so we can just write this one. And the derivative of this will be equals to ln of a multiplied by a to the power 3x minus 2y. According to the chain rule, we also have to differentiate the exponent. So the derivative of this 3x with respect to y will be equals to 0. But here it was with respect to x, that's why it was 3. But in this case, it's with respect to y, so this will be 0. And the derivative of negative 2y with respect to y is equals to negative 2, because our partial derivative has y and not x. So this negative 2 multiplied by this positive 3 will be negative 6. This ln a multiplied by that ln a will be equals to ln squared a multiplied by a to the power 3x minus 2y. So this will be our answer for question 1.1.2. Question 1.2, we are given the parametric equations x is equals to 1 over 1 plus 2t and y is equals to 1 plus 2t. And 1.2.1, we have to calculate in terms of t dy over dx. So this dy over dx is equals to dy over dt divided by dx over dt, and the dy over dt multiplied by, so we change this division sign, so we have to flip so that we can have dt as the numerator and dx as the denominator, so that dt and that dt will cancel out each other, and finally we dy over dx. But our focus should be here, so we have to find dy over dt and dx over dt. So x is equals to 1 plus 1 over 1 plus 2t, and y is equals to 1 plus 2t. So the derivative of y with respect to t, the derivative of 1 is 0, the derivative of 2t is equals to t. We take this 1 plus 2t in the denominator and we make it, and we take it to the numerator. So this will be 1 plus 2t raised to the power negative 1. So dx over dt will be equals to this negative multiplied by this whole thing, 1 plus 2t. Negative 1 minus 1 will be negative 2. And also we have to differentiate the inner function. So the derivative of 1 is 0. The derivative of 2t is equals to 2. So dx over dt will be equals to the 2 negative 2, 1 plus 2t, and this to the power negative 2, and this will be equals to negative 2. So now we are taking this 1 plus 2t raised to the power negative 2 to our denominator, and this will be 1 plus 2t squared. So if you were to use the quotient rule here, you will still get the same answer. So from here, to determine dy over dx, like I said, you just have to divide the dy over dt. The dy over dt is 2, and you divide it by dx over dt. The dx over dt is negative 2 over 1 plus 2t squared. So we change this division sign into multiplication sign, and this whole thing will flip. So we'll have 1 plus 2t squared as our numerator and the negative 2 as our denominator. So that 2 will cancel out with that 2. We'll be left with that negative 1 plus 2t squared. So dy over dx will be equals to negative 1 plus 2t or squared. For question 1.2.2, we have to evaluate d squared y over dx squared. And to evaluate this integral, we have to use this formula, which is not available on our formula sheet. So d over dt multiplied by dy over dx multiplied by dt over dx. So we already have dy over dx, which we will differentiate with respect to dt, and we have to determine what dt over dx is. On our previous question, we have dx over dt, so we had dx over dt, and this was equals to negative 2 over 1 plus 2t squared, but we need dt over dx, not dx over dt. So to determine dt over dx, we flip the dt over dx, and so what you do on the left, you also do on the right. So since we flipped the dx and it came at the bottom and the dt came on top, so we also have to do the same. So this 1 plus 2t all squared will come and be our numerator, and this 2 will be our denominator. So in the place of this dt, in the place of that dt over dx, we will substitute negative 1 plus 2t squared divided by 2. And we also have dy over dx, which we determined from question 1.2.1 as negative into 1 plus 2t squared. So we have to differentiate it with respect to t. So we have to differentiate this with respect to t. So when we differentiate, so this d over dt, dy over dx will be equals to, so we differentiate this whole thing. So we start by differentiating the brackets. We minus 1 to the 2 and we get 1. And we also differentiate the inner function. The derivative of 1 is 0. The derivative of 2t is 2. So this is equals to that part, and that last part is equals to that part. So we simply have to multiply these two will be equals to negative 2, 1 plus 2t multiplied by 2. So this 2 multiplied by that 2 will be equals to 4 multiplied by the dt over dx. So the dt over dx is negative, so that negative multiplied by this negative will be positive. 1 plus 2t squared over 2. 4 divided by 2 is 2. And this 1 plus 2t multiplied by that 1 plus 2t squared will be 1 plus 2t raised to the power 3. So the bases are the same. We have to add the exponent. So this will be our answer for question 1.2.2.